Good day to all. Today we are going to see about that overview of sensors for robotics. See what makes a machine as a robot. First, here you can see this one. It is for use for digging purpose. This truck. Here first one is it's sensing the information about the environment. Then we have a planning, then acting. Action on this environment. Then here, why do robots need for sensor? Because some places we need for some certain angle for some purpose. So this is the angle of arm. Here we'll have arm with the help of that some particular sensor. What is sensing? Collect the information about the world, which is a common thing here. The sensor is nothing but an electrical or mechanical or chemical device that maps an environment attribute to a quantity measurement. This quantitative measurement will have attribute mixtures, often no one to one map, and hidden state in that environment. Each sensor is based on a transaction principle, which is a conversion of energy from one form to another form, is also known as transducer, as we saw before. Then why do robots needed in that particular sensor? Sensor is used for sensing some particular element, as we know already. So if the any particle will move somewhere over here, if we will have a sensor over here, means if the particle will come here, then this sensor will sense some particle will come. Likewise, we will have a sensor used in that robotic. Then see here, you can see this automatic running machine. If it want to hit anywhere, how it will detect whether the object will there or not? So we will use some sensor over here, this instrument. That instrument will detect that the object will above or near or beside from that particular roller. So likewise, this the sensor will detect if anything behind them, which is called optical detection. As well as see here, this machine is used for automatic harvesting. Here is where it is the crop line, because it shouldn't be go outside from that particular land. So here also some sensor used here to do not go for the outside. Likewise, the automatic material handling machine, where are the fork holes? Likewise, it will sensor. This is also one of the sensor for face detector. We can use nowadays in that our mobile also to recognition of our face. If our face is shows in front of that mobile, then the mobile will be open. Likewise, we will use that facing the sensor to open the mobile. Then the types of sensors. What are the types of sensors there? First one is active sensor and another one is passive sensor. What is the meaning of active sensor? It is a signal into environment and a measure interaction with the signal with the environment. For example, radar or sonar, those are all active sensor. The passive sensors are record signal already present in the environment. That is the passive sensor. For example, video cameras. These are all the example of passive sensor. Whereas active sensor is send a signal into the environment which is not already in that environment. If it is in the environment, that is called passive sensor. The classification medium used here in that type of sensor. First one is it is based on that electromagnetic radiation of various wavelength. Then the vibration is in a medium, concentration of chemicals in environment and by physical contact. Then extracoptive deal with the external world, where is something how does look like a camera, laser, rangefinder. These are all the sensor. Then prosperative deal with the self. This is for a world. This is for self. Where are my hands? For example, encoder, stress, receptors. Am I balanced? For zero of INS. These are all called about that sensor. The simple practical sensor that we can purchase, which is touch sensor. We'll know about the touch sensor and tilt sensor, encoders, bend sensor, light sensor, temperature sensor, potentiometers, laser rangefinders, and also the cameras. See, what is that touch sensor? It is a simple switch. See, we will have a force here, and if we are touching here means this coil will get energized, and this will denote the voltage measurement here, then the electrical will flow. This is the simple example of touch sensor. And tilt sensor, this is the tilt sensor, another example of that switch. According to that gravity it will work. Then the encoders measure rotational motions. They can be used to measure the rotation of a wheel. See, in that particular wheel, it is used to calculate the rotation. How many rotations are happened in that particular systems. Likewise, we will see from this encoder, and they can be used to measure rotation as well. The servo motors used in conjunction with an electric motor to measure the motor's positions and in turn control its positions. This is the example of that encoders. See, already we know that the square wave of that particular voltage. If it is in off stage, that will be 0. If it is on stage, that will be 1. Here it's a 0 and here it's a 1. We know already if it is in off, that's a stereo stage, and if it is on, that is in the on stage. Here the important specification is number of counts per revolution. See here it's off on time. One off on time and second is off time, third is on time and fourth one is off time. This on off time it will blow and count that particular systems. This is the sample problems for that Ohm's law. We can find out the voltage. How we will calculate the voltage? As we know already, its voltage is directly proportional to that current. So V equal to IR. V is nothing but the voltage, I is nothing but current, and R is resistance. See here, if you are taking this one, here we will have a one resistor which is 1000 ohms, and this is 9 volts, and current passes through there is 0.009 amps. For that, we easily will calculate if it is current is 1000 ohms and resistance is 1000 ohms and current is 0.009 amps, means if you are multiplying these two, then we will get that voltage 9. And the electrical analogy, this is the electrical analogy. See here it's voltage, current and resistance. A larger pipe is less than the resistance, so it will come for more water. A smaller pipe is more resistance, so less water. Do you understand? See, if it is a size in big for that resistance pipe, then the water will flow huge. More number of water will come here. So if it is a resistance is more, we will have a current similar like that. From that formula, V equal to IR. So if it is the pipe is big, then we will have a more voltage. If the pipe is less, we will have a small voltage. C equal to I equal to V by R. So smaller pipe is more resistance, so less water. Large pipe will have a less resistance, so more water. Thank you.